All right. Well, otherwise, if we're good to get started then, generally how this goes, I'm sure you guys are familiar, you've done this before, but just a general sort of overview of the rocket. Usually I like working from the nose down to the aft, and I'll kind of ask questions as we go. And at the end, after we sort of get through all of our rocket review and questions, I'll ask you guys a few just logistical questions. And then at the very end, I'll leave it open floor for anybody to ask any more questions about the competition, about the project, about anything and everything. Sound good?
Okay.
All right, yeah, so if you guys want to get started, I like kind of getting the close-up view of the rocket, each different part, sort of walk me through, what's going on in the nose cone, what's it made out of, and we'll just sort of work our way down from there.
Yeah, we have a phone here that we're going to try to use as a camera so you can get up close.
Sounds good.
Let me get away from the camera.
Well, there it is in selfie.
Oh, it can't turn around?
It's not focusing right now. Blurry, right? It's blurry. Oh, the background blurred, that's why.
No, there.
Sorry for the technical difficulties.
I think I know how to do.
No worries.
Yeah.
Is there no like double tap to just grab?
Oh, it's because
No, try on this.
well, that's okay. We can just pick up the laptop.
Wait,
Well, it's just mirroring up there, so it's still going to be all here on the laptop. Yeah. Okay, so oh, whatever. We can work like this. All right. Well, it's your guys' nose cone.
Okay.
You guys made it.
Awesome. So this is the nose cone. It has a fiberglass body and an aluminum tip. I made it out of fiberglass because we need some radio transparency for our what's it for specifically?
It was cameras that was
For
gonna
the
be up there.
cameras. You hold it. Yeah.
Well, you're tilting it up.
Yeah.
Yeah, you tilted it up. That's why it's getting stuck.
Yeah, you jammed it.
There we go. Okay, cool. So the entire thing is fiberglass except for the tip, which is aluminum. It's attached in the inside
just
with
hold
a
it still.
fiberglass washer. Right.
And
So
is that coupler epoxied into place then in there?
It's an integrated coupler. It's all one big piece.
Okay, cool.
Yeah. So this section here will be bolted to this carbon section here. We also made this here in-house. This is made of carbon fiber. This will also house our main chute where it'll be housed for, and this is, like I said, it is bolted to the like little integrated coupler for the nose cone, and it will have shear pins that goes into our coupler section, which is right here.
How many shear pins are you using and what size?
It's still to be determined in the ground ejection tests, but as a baseline from last year, I believe it was 5 440 shear pins, and also based from last year, I think our main ejection charge was for the nose, I believe it was 7 grams for primary, then 8 for backup.
Okay, so you have not completed your charge testing yet?
No, not yet. We're hoping to do that this weekend.
Okay, sounds good. Yeah, I'd love to hear the results when you guys do get around to that, and just let me know how it goes and if you had any issues or anything like that.
Okay, will do.
For the bolted connection and the nose cone, what size fastener are you using and how many there?
So it's going to be a 1/4 inch 20 eye bolt, and then also there's going to be a bolt right next to it. That way I can put some wire around the bolt and the eye bolt. That way it doesn't loosen itself or rattle itself loose during flight.
Oh, is that going to be on the bulkhead of your nose cone? Or I guess I was referring to what's attaching your body tube to the coupler there.
Oh, okay, sorry.
But good to know on the eye bolt as well. I was going to ask that too.
It's still to be determined, and that's because we've just been mainly focusing on some other parts of the vehicle, as we'll get to here in a minute. But we do already have that lined up and planned. We already know for sure that we're going to have at least 3 bolts with some nuts. It's kind of simple.
3/4 20s will hold it on.
Yeah, 3/4 20s, like nothing too crazy, but nothing too simple. So moving on, we have our coupler section that we also made in-house. This section was made with the requirements and guidelines for space protocols, which needs to be at least 1 caliper's width going into each like section of the body tube. This is going like I think almost 1.5 times longer than that. So plenty of length going into each part of the body tube. And this section here is made from fiberglass that we also made ourselves here in-house. And also the switch ring, which has not been attached, but we will attach it soon. It's because we're still making sure our avionics is like where we want it and we're going to be sure about it, but it's also made from fiberglass as well. And it just slides into our tube.
Yep.
Are both of those separation joints then? Like, do you have parachutes on either side?
Yes. So the drogue chute will be in this lower half of the
Drogue
body tube.
drogue is on the lower.
And then the main chute will be up here, which are both separation points. Yes.
Okay.
What do you have going on in your nose cone then? Do you see you like a camera or something in there?
Yes. To be honest, right now the camera is if time and budget allows. Otherwise, it's just going to be empty.
Good. Okay.
Do we want to talk about this or just
let's finish with the rest of the structure, and
finish
then we'll
with
come
the
back to
rest
the
of the
abduct.
structure? All right. Very cool. So this is the middle carbon fiber tube, and it just connects the lower half of the vehicle with using the motor. So we integrated the motor to be kind of like a permanent coupler, a structural coupler component. That way it can like combine the aft section and also the motor to the rest of the forward vehicle. The way we do this and to prevent it from like separating or just spinning as it's going in the air, we made these little brackets ourselves. Here, actually, yeah.
There, where's the camera? Right there.
Yeah. A beauty.
So yeah, this will be bolted through the carbon fiber airframe just with a clearance hole, and it will bolt into the forward closure holes of the motor case itself.
Okay,
Yeah.
so like you have a bolt going through that empty hole through your carbon fiber and then into the metal of the closure below.
Yes.
Is that how your motor is retained, or do you have other retention methods as well?
That's how the motor is retained to the airframe. The front of the airframe also has a big old eye bolt, and that's where the recovery point will be to the main section of the rocket. Sorry.
All right, so do you just have the one bolt going in from your motor casing into your tube?
So at the top, there's going to be 4 of these all
there are
around.
4 of them.
Yeah.
Oh, okay, got
we
it.
got a
And then just
whole
one of them has the.
Yeah, we have a whole pile of them here, and that's also where the rail buttons are mounted to.
Want to keep on to it?
Sure.
Okay.
And then the last piece of body tube that we also made, but also with our fin can that we made in-house as well. All of it's made from carbon fiber. We did all the compositing here as well. We made sure, consulting, of course, other resources, that we made sure this is going to be strong enough and suitable for our need. This is very overbuilt for what we truly need it, but it's better to be safe than sorry. So that was the idea here. And then the way that this prevents itself from spinning around the motor casing is we have the same brackets that we mentioned earlier. They are going to just be a simple bolt that clamps the actual carbon fiber tube to the inside of the motor casing, and that's it.
Yeah.
So then is all the thrust from your motor transferred in through those bolts that go through those little aluminum brackets on the outside?
There is not. There's also a big thrust ring here that sits over the boat tail that will push on the bottom of the rocket right there. That's the primary way that thrust will be transferred into the vehicle.
Okay, got it. So you got there, and then you got 4 bolts around the bottom, 4 bolts around the top that hold the motor into those different sections of body tube.
Correct.
Do you have any sort of like alignment feature to make sure that your rail buttons because it's on 2 different halves of your body tube, right? Do you have any alignment features to make sure that those are nice and straight on there every time that you assemble it?
That's in the motor case itself. The holes are very, very close. And like just by virtue of like the holes already being drilled in the motor case in a line, that you can't really mess it up.
Okay, so there's only one sort of orientation where they'll even go together.
Yep.
All right. Chris, you got any other structures, questions before we move on to some of those other details?
I don't think so. I think that's reasonable. I'm good with that.
All right. You guys want to jump in and talk about some of your recovery parts, either your avionics bay or your parachutes and recovery system?
Okay. Want to start with avionics?
So this is the avionics bay.
The area spawn, it's obviously unfinished at the moment,
Yeah,
but
it's-
this is the general idea.
Yeah, it has fiberglass bulkheads on the end. They're epoxied and then they're lathed. And then this was 3D printed filament. It has our main altimeters on this side. So we have our primary, it's the Stratologger CF Perfect Club Light. That's going to be our main one. And then we have our secondary one on this end. It's just the Blue Raven. And then we're going to just wire them up to charge wells on each side, 2 and 2. And they're both with the 6.6 volt LiPos, I think.
Yeah,
LiPo for,
lithium ion phosphate batteries.
yeah. And then we're just gonna attach some separate connectors, wire it up. And on this side, we have our recovery GPS. I don't know if you can see it. It's just the featherweight GPS. I think that's also by Blue Raven, right?
Featherweight.
Featherweight. Okay.
Yeah.
And then we just have 2 screw switches on this side and then the other battery. We don't have the other battery right now. It's a work in progress, but this one goes into this little fiberglass coupler. And then it has 2 eye bolts on each side, and that's how the parachute's attached.
Yeah.
Those.
And then
Is it-
I'm sorry,
is
go
it-
ahead, Chris.
Yeah, is your featherweight gonna be obstructed or occluded by that top
It's
carbon fiber tube?
it needs to be moved to the center section.
Uh-huh.
Yeah,
Yeah.
I did see that.
Yeah, some of these are a little out of order, but we just kind of, I need to reprint some parts, so it's working.
Okay.
Week.
Is that supposed to like I see the stair step on it, so you're going to bolt it and have it kind of free floating on either end with
Okay.
with all
Bolt
threads?
ends
Yeah.
for each part. So these, we have some eye bolts that actually go through it, and they're gonna clamp down on each side. So it's gonna clamp down on the top of the coupler, and then these have little nuts each between each unit, and then they're gonna clamp together. So it's not gonna be like free floating in the middle.
Okay.
Yeah,
And then where does the harness attach?
the harness,
To the eye nuts.
Yeah.
These will obviously be cut to length, but there will be eye nuts on this end and this end. And then a Y harness will attach to the rest of the recovery.
yes,
So you got Y harnesses on both sides of that?
Correct.
yes.
Okay.
These just need to be cut off. They're too long right now.
Yeah,
but
That's
we
just
have
how they
to
came
put
from the
them
hardware
anyway.
store.
So,
Yeah.
yeah, that's the avionics. I don't know if you have any questions to
Yeah,
ask.
I got a couple for you. So you have 2 screw switches, but you have 3 devices on there. Which one are you arming your featherweight differently? When are you arming that?
The featherweight is just going to be plugged in for the battery and it'll run until it's dead. And then
Yeah.
the other 2, those are going to have the screw switches on them for the charges, so we can arm them at the pad. We're
I
gonna
think
yeah.
I think that DTEC says you have to have a switch on your GPS.
Yeah, I am gonna have you guys add a switch, and the reason being is that if we've got a bunch of people having their GPS and other trackers on, while they're, in that setup area, while they're staging to go out, we suddenly have a lot more GPS radio frequencies all floating around at the same time. And so we get a lot more conflictions. And so to try and minimize as many frequency conflictions and just way overpopulation of radio, because it's a very RF dense environment, we do want you to be able to turn those on once you get to the pad, not once you're assembling your rocket.
Okay.
Okay, easy enough to add on a switch.
Yeah, and on the switch, and then you should be totally good to go and just arm it with the rest of your electronics out the pad.
Okay.
Perfect.
It looks like you have a CubeSat form factor down the middle of that. Am I reading that correctly, or
That is correct.
something going in there?
In an effort to save space, we have it's basically the integrated payload bay and av bay. The CubeSat will basically slot into there, and it will be held in place on either side with the bulkheads.
Got it. Do you have your payload available to show off right now too?
Unfortunately, we do not have the payload at this moment. The member who is working on payload has to move out of his dorm today, and so he's been a little busy.
Gotcha. What is
Is
the
it aluminum or what's it made out of?
It's primarily 3D printed.
Okay.
what is the structure of those black 3D printed parts right there?
So basically they have round spacers. I'll get a little closer. They have round spacers at the top, and there's 6 of them. And then each side is held by the Allen key bolts and nuts on the other sides. I have to 3D print them because the holes are a bit too big, but they're basically just gonna thread right in, and there's 2 trays on each side. And then everything kind of just gets sandwiched together and bolted.
What material?
PET G.
Yeah, it's all PETG.
It's a little hard to tell. I'm almost just like a touch worried just on there's some really thin parts it looks like. It may just be not coming through on the camera very well. But I'd encourage you to just sort of double check how that is all set up, especially once you have the payload in there. If the payload's adding that structural integrity, it may not be an issue. But I hate for, especially if you have a hard landing, for you to start crumpling some of those or just having them be really, really fragile. And it's kind of what it looks like, but it's a little hard to tell.
Yeah. This would actually it's an evolution of the ab bay design that we used last year, and it held up fairly well for its flight, even though we did have a recovery issue there where we shredded the main, and so we landed a little harder than expected. But even then, it still held up decently well.
Yeah, okay.
The ab bay design is something that has flown before.
Sure, sounds good. Okay, that makes me feel a little bit better if it's very similar and it survived a hard landing. Do you have any other details on your payload that may be relevant? Like is there any unique aspects that may pose any sort of implications to your flight, or what's going on with your flight?
Not really. What was our payload? It's C. elegans, which is a type of tiny microscopic worms.
It's a type of
Well,
nematode.
it's a little worm.
It's a-
So it's mostly just gonna sit in its little CubeSat box and not really interact with anything else.
Yeah, the
Yeah.
experiment is basically just housing. It's an observatory experiment. There'll just be a run cam running that would like battery pack and hope. I don't think we're gonna go with any sort of cooling. I think we'll have some fans, but it's just gonna be a little disc with a colony of C. elegans, and the video will just be recording that, and it'll download locally to an SD card that we'll pull to give to our biomedical researcher after.
Got it. Are you arming that run cam at the pad, or how are you ensuring that it will have a long enough battery life?
I'm not sure what ISAC's plan is for that. I think probably arming it at the pad would be the best.
Yeah, it's just with a very large battery.
Yeah, so probably installing an additional switch for that as well.
Yeah, I'd recommend having that or some sort of access board, just kind of depending on what sort of run cam you have, especially since, similar to last year where we had that quarantine procedure. If you're kind of getting into that FSRQ near the latter part of the day, the weather may not be good enough or the range may be closing too soon for you to launch. But we're going to allow teams to go into an overnight quarantine so that they can like literally get there in the morning and launch first thing. And so the deal with that though is you have to put your rocket in the quarantine area and then you can't touch it until you're putting it out on the pad. So if you have batteries that are burning overnight, that obviously wouldn't be good. Or if you have an SD card that's trying to fill up with storage, also probably not the best. So just keep that in mind, and I'd encourage you to find a way to arm that at the pad so that you can still get some nice video.
Okay. Okay, and then I guess we can move on to the rest of actual recovery. Start at the top. This is basically our shock cord. It's 50 feet of, I believe this was half-inch tubular Kevlar, just with big quick links that will obviously attach to the eye bolt that's in the nose. And then on the front of these, there's the two eye nuts leading to the Y harness, and that attaches to this other end. This is our drogue parachute. It's just a regular 55-inch chute with a spill hole. It's on a swivel. Everything attaches with quick links. Nothing super fancy. Obviously housed in a little fire blanket. Moving down to the main parachute, we have a 144-inch Iris ultra compact parachute here. I don't want to open it because it's quite a pain to unfold it or to refold it, but it's the same basic idea. Here's its shock cord. It's basically identical to the other one, just has much larger swivel on it. And same attachment point on the ab bay. And then that just goes into the main parachute tube section, which goes to here. This is the forward closure of the motor. This is where our recovery point will sit. This is which one was this? This is this is a 3/8 eye bolt that will go in there. To keep it from unspinning, we do have we have a pressure port here. And so we're just going to safety wire to that so that it won't unspin. That's most of recovery. I don't have the deployment bag here. I think that's out there somewhere, but we are going to have a deployment bag to help deploy the main parachute. And that also has its own pilot chute, which left out in the makerspace.
You haven't made the Y harnesses yet?
Where's our box? You leave it. I think it's all out there. Can you guys go get it?
They're out in the makerspace. They'll go get them real
Yeah.
quick.
And what size all thread is that?
The all thread?
Yeah, through your eBay.
5/16.
5/16.
All right. So 2 5/16,
Mhm.
and then you said an eye nut, basically just thread it onto the top of that
Yeah.
all thread.
Yeah, and then we'll safety wire everything so nothing comes on loose. So
All right. Jam nut, whatever.
yeah.
I mean, if you got two of them, you can't unspin. Yeah.
Yeah, but more safety wire doesn't hurt either.
Right. Okay.
Yeah, something I usually like to check with teams. It's generally after they have ejection charge tested or flown. I know you guys haven't yet, so my request for you is once you ejection charge test and you get your satisfactory results, just make sure you do a careful once over of all of your shock cord, your parachutes, your parachute protectors. Make sure that they're not too damaged. They can be a little bit stained from the black powder.
Yeah.
But that's fine. I'm more worried about them being damaged that would impact their performance, so that you recognize that before we're checking them out at the flight safety review in Texas.
Yeah, of course.
Yeah.
That's something we'll obviously look over once we do the actual deployment test.
So that's one of the questions I usually have, because like the vast majority of rockets we fly, you can't hardly fit the parachutes in, but when you get into a big rocket, then the parachutes like roll around and the burrito unwraps, right? Are you doing anything to address that, or are you concerned about that at all?
So the deployment bag, this is not the actual deployment bag. This is one that's too small. This is just one we had around. I'm gonna make one that's basically the same thing, but when it's expanded, it's gonna be pretty much the same inside diameter as the rocket. So it will fit in there nicely. And since it doesn't really, this fabric doesn't really stretch that much. So that's how it's going to be contained and not be rattling around too much. It should be a
I
tight
gotcha.
fit, but still slide out.
Yeah.
But it's a regular deployment bag. This goes to the bridle on the spill hole of the parachute, this end, and the pilot parachute is up here. You stuff the chute in there, and then the lines go into
That's for the main, right?
for the main. Yes.
Okay, so on the other end, you're using a fire blanket,
Yes.
and I think the other end is also a much larger tube section. True or false?
Yes, that it is. Okay. You bring up a good point. We do need to figure out a way to keep everything together in there.
Yeah, I mean, like, by the time you stand it up, lay it down, inspect it, bounce it around down the road to get it out there, like you're gonna unroll your burrito in there.
Yeah. Okay. That's something we're gonna have to revisit, but yeah, that's a good point.
Stuff it in there and pile dog barf on top of it.
We do have a lot of dog barf. Yeah.
But
Like a tiny fraction of the amount we have. Yeah. Okay, well, that is one potential solution, which
yeah, figure something out.
there's still time to do that.
Yeah, definitely a good thing to, try sorting out, practicing back at home before you make the trip on over to Midland.
Yeah.
Yeah, I like videos. I want to see video of that
Oh,
ejection
For
charge.
certain. That's definitely one of the things we have to video.
All right.
Yeah, and same here. I'd like to see the video when that comes through as well.
Okay. Okay, I think that's most of the recovery stuff. Were there any other questions that you had?
I don't have anything else.
I think I'm good on recovery. You want to go talk about your motor?
Okay, we can talk about the motor. You guys let me reveal the motor. Yeah, just take everything apart. Okay, so this is the motor. I guess we can start at the aft end. This is the boat tail that we're using. This just slides in there with double O-rings. pretty straightforward. And then we have this section here, which, as you can see, it's already been fired. So this hardware does work, and we have a video that we can show you. That just slides in there, and then the actual nozzle, which is graphite, slides into there. And then that would all go into the aft end. There's 8 bolts here. They're all quarter 20. Yeah, it's pretty simple. This is a fresh one that isn't fully machined yet, but you know, it's in progress. This is the case. It's quarter-inch aluminum, 61 T6. This one has already gone through 3 successful fires and then 1 minor mishap at the beginning of last year. So this is also flight proven. And then this is the forward closure. Again, it's a pretty standard forward closure, just more O-rings, a little slot for the liners to sit on. It's tapped for a pressure port. Obviously the recovery point from earlier. Then there's this little spacer ring that sits right there to put this at the correct distance wherever it needs to go. And then this retaining ring where everything gets bolted in over here. And then this is just through holes in here. We have nuts on the backside that will hold everything together.
So how are you going to do that when you put that tube on top of it?
I mean, we still have those well
long-
nuts that we used last year. So I was just going to do that on the bottom side here. It's only 4 bolts that need to be bolted from the outside. All the rest can be pre-bolted before the other tube gets slid on. So
Yeah.
for those well nuts, I mean, I have them. So
Okay. I'm not necessarily worried about the strength per se. I'm worried about how long your arm is and your ability to
yes,
get in there to screw the nut.
that's what those floating nuts will be for.
All right.
Because, I mean, we can't stick our whole arm down the tube. It's too long.
Okay. Have you practiced that yet?
Not yet.
Okay.
But yeah, I know that's going to be definitely not an easy assembly, but it is
Right.
something I'm aware of.
Okay.
And yeah, that's mostly the hardware for this motor. It's pretty simple. A lot of the effort went into making all this stuff lighter from the previous year. I think I ended up taking nearly 20 pounds off all this hardware. And I mean, it's already been fired. It works.
So how did your motor perform actually versus what you expected?
I still need to do a little bit more data crunching on that because this was my mistake. I had the wrong load cell profile, the wrong load cell calibration. When I did the data, I still have all the raw data, so I can go back theoretically with the correct calibration profile and get the actual thrust data off of it. I just haven't had much time because, I mean, I just finished finals yesterday, so hopefully I'll get some time to do that this weekend. But
Okay.
the pressure, it was a little lower than what the simulation than what we were expecting in the simulation. But the shape of the thrust profile, along with the pressure profile, was pretty much in line with what I expected.
Okay. So the profile matches. Wasn't any weird spikes or a weird
there wasn't.
ramp or anything. It was just
Yeah.
the total number was lower than you expected.
Yeah, the software thought it was like an like 3200 or something like that, which obviously is not correct. So the correct like load cell calibration needs to be put on there.
Okay. Do you plan on flying it?
Are
you going to test fly this, or are you just going to fly it?
Yes. Yeah, we're going to be at Texas Shootout.
Okay.
Yeah, we'll be
So
there.
you're also planning a test flight with this motor before the competition?
It's a slightly different motor. It's the same hardware, but it's not the same motor that we're planning to fly at Spaceport. So like we have the 2 sister motors. The one that we test burned a few weeks ago is the one that was poured at the same time for the one that's going to fly midport. Sorry, that's going to be flying at midport. This one at Texas Shootout, it's a different motor chemistry or different motor profile that we're going to fly.
Okay. Is it kind of like a little similar? Are you still going to about 30,000 feet on that one? Or?
It's probably not going to go as high. I haven't fully finished designing the motor, but I can tell you it's not going to go as high. There's a lot less. There's like 20% less propellant in it, so it's still high, but not quite as high.
Yeah, you're doing an airframe test and a system function, but not an altitude test.
Yes,
Okay.
but it'll still be high enough to fully test all the other systems out.
Gotcha.
Sounds good. Yeah, I'd definitely be interested in seeing the data that you have from your static fire for the motor that you're planning on actually flying at the competition. So whenever you finish up crunching those numbers, I'd like to see them, just kind of compare them to simulated values, and I'd also like to see the video that you've got from that one too.
Okay, we can definitely just pull up the video right now, right? It's in Discord somewhere.
Yeah. Well, I couldn't post the GoPro video, but I have the other video.
The motor test?
That's fine. Yeah, the motor test.
So just like hold it up to the camera or?
Like, because I'm on, well, we'll do it for mine, because I'm on Zoom too.
Did I not put it on? They burnt it my property, so I have copies.
That's good.
Share.
Oh, hold on.
Give him permissions.
What?
I don't know how to do that.
What does he need?
Permissions to share
Permission to
video
share.
or like,
Oh, from which one of the users here?
he's Emilio.
I'm like
Amelia one?
There should one be in there being that's my name.
I can remove him.
That may work.
There it is.
Is it letting you?
Okay.
Hopefully you guys can see this.
I do. We're good.
Well, that's not a good one.
I'm not sure if there's audio, but
Get the one Jared to.
So I can't post that one to Discord. I have it on my phone.
Me too.
Because it's like it's just too large to attach on the Discord.
Yeah, looks like a good burn overall. So I'd definitely be interested in seeing that data though. I am curious how much lower was the pressure that you ran versus what you expected.
It was pretty low. It was around 400 psi, if I remember. But
no, not that. It was like about 450, and we were expecting 600.
Do you know why it was so much lower than you had predicted?
I'm not entirely sure. Yeah, I'm still fairly new to all this motor design stuff, so I'm not entirely sure what could have caused that to be that low. Honestly, the biggest source I can think of is just poor calibration on the pressure transducer.
But yeah, I'd be curious to see if it was something like you had a lot of erosion in your throat, or if you think it's something to do with the original characterization of your propellant.
It might be that because we have the nozzle here, and there's pretty much, I mean, it's hard to tell, but there's no erosion. It's hard to see, but like these little corners are still very sharp, so there's not really any noticeable erosion.
Have you measured the throat diameter compared to pre-static fire versus post-static fire?
I have not actually. That's a good idea.
Yeah, I'd recommend taking a look at it. You know, I'd rather your motor at the end of the day be a little bit safer in a
Yeah,
static fire than a little bit more aggressive than you thought it would, and especially something that may risk a KATO. But even then, I'd be interested in seeing a little bit of analysis as to where you think you went wrong, just so we understand and can sort of track that down for your guys' like learning in your propulsion development, but also so we know that it's not going to potentially lead to any other issues. You know, usually it's not as much of a concern, like I said, if you're running a lower pressure. But also we don't want you guys getting too low of a pressure where you're, you know, going to have issues with combustion or, you know, really underperform or things like that.
yeah. Okay, yeah, that's definitely something I'm gonna have to look into. I just measured it. The throat diameter was 1.85, and it's it's right on the money. There's not really any noticeable erosion there.
Not on the graphite part, right?
Not on the graphite part, correct?
I mean, you've got sacrificial uh middle piece in there, right? The your little Russian doll setup,
Of all
the
the
phenolic.
around it. Yeah. Well, one thing that did change is like I am changing the design of this thing because you can see it got pretty toasted on the inside. And what I think happened is previously, well, let me get the nozzle out. There wasn't much in the way to stop the O-rings from like seeing the direct flame front. And so that's why that got all burned on the inside. But on the new one, it sits in there, and then there's this little top cap that sits over that joint. So that should definitely help the phenolics survive better.
Are you putting anything besides O-ring to seal between those?
Between the graphite and this big carrier part,
Yeah, just wondering if you're using like RTV anywhere in your nozzle assembly or something similar.
pretty much the only RTV and the nozzle assembly will be holding this thing holding on top right there. And that's it for RTV.
Well, not true. Where else do you use
Well,
RTV?
RTV and the holding the grains to the liner is the other
Grain
place.
bonding, yeah.
Yeah.
Okay.
But in the nozzle assembly, that's the only thing that will be RTV'd. Just that on top, so it doesn't move around.
And do you think it was possible in your static fire that you were just having a lot of gas seepage around your nozzle? It's like, does it feel loose at all, or just like a little bit toasty between the two?
Maybe a little bit, but I don't think it was enough to contribute too much because it's still like there's not much of a gap between the nozzle and the other part.
Are you going to reuse that when you fly it?
This part, the phenolic part?
Correct.
No, these are one-time use things.
One time? Okay.
No, this one, especially this one, is far too burned for me to feel comfortable reusing it.
Can you see the other end? Because that's the inlet. There's the divergent. Oh yeah, divergent's pretty.
Yeah,
Pretty
no, I would not want to reuse this one.
Gotcha.
So that's why we have a brand new one that isn't done yet, but we
Okay.
can.
And you've got enough to finish the one you had and make another one?
Yes, we have enough stock to do that.
All right.
I have a couple more questions just on your case. Wondering where your design failure mode is on your case and what the safety factor is on that.
So design failure is at the rear end. It has only a single row of bolts here. Whereas up at the top, it has 2 rows of the same bolt pattern, just offset by, there's 8 of them. So like 22.5 degrees is what they're offset by. The factor of safety on that one, I'd have to go look at my spreadsheet again, but I think it's around safety factor of about 2 more or less.
Okay.
And the failure mode would be those bolts shearing and the rear closure shooting out the bottom.
Tell her how you know.
Because it happened.
This year, or was that the last year issue?
It was last year. It happened last year where at the first static fire that was attempted, it was upside down just like in the video that we just showed you, except it overpressured. It shot the nozzle out like 400 feet. The whole grains, like the whole grain stack, jumped out of the motor and started burning right next to the motor. And we got very lucky that just our test stand got damaged, but not the case itself.
Wow. Well, I like that you still have your failure mode down at the nozzle. That'll definitely be good in case something like that were to happen during flight. But yeah, I think, like I said on the motor, just like to see the test data after you've done the recalibration.
Yeah.
And whatever you kind of determine as your reasoning for burning a little bit lower, I think that'd be good to dig into a little bit more now that said that you've wrapped up with finals.
Yeah, I just had my last one last night at like 7 at night. So yeah, I'll have a bit more time for all this stuff now.
Gotcha. Okay, I think that's all my questions on the motor. I have a few just general sort of like simulation rocket questions, unless Chris, you got anything else on the motor?
Nope.
All right. Do you guys know what your minimum stability throughout your flight profile is?
Yes.
Yes, so the like minimum like it says at the very end of our motor that it's going to be 1.25, but that we're honestly going so fast that that's not actually technically true. When it's standing on the pad, the minimum stability is around 2.95, 2.98 calipers, so it is way more than like than safe. So we for sure know that it's going to be stable off the rail and during flight. The point in which that it actually reaches that like minimum stability is allegedly, according to Open Rocket, is towards the end of the motor burn. But like I said, we're already moving so fast, we already had to expend all that propellant that that will really play a factor into it.
Have you used Ross Aero at all to simulate and look at the stability there?
I'm sorry.
Ross Aero.
Yes, it is giving the same. I would have to actually look at it, but it is almost giving the exact same number. I do remember, I think it was saying like at the end of the motor burn, it was around 2 point. Oh, I don't want to give you the wrong number, sorry, because I don't have that information from me. But yes, we made sure to check on that. Oh, there we go. We have the simulation from Open Rocket that's showing the stability margin versus the flight time, and you can see the motor burnout like kind of around there. It says that it's allegedly going to 1.58 around there.
5.8
Yeah.
from Open Rocket at least.
Gotcha. And do you know what speed approximately you'll be going?
Yes. Yeah, Open Rocket has it there.
Yeah.
And in this simulation, are you using still your simulated motor thrust file versus what you've just tested?
This is the simulated one, yes.
So you haven't rerun the numbers with the updated values?
Yeah, it still needs to be calibrated as Amelia was saying.
Okay. So
Yeah.
you're going to wait until he's done that, and then you'll create a new ENG file and run that?
Yes, sir. That's the plan.
All
Yeah,
right.
I'd be particularly interested in how that changes your off the rail velocity, especially if you're having a lower pressure burn, you're having a little bit lower average thrust than you may have been simulating to. I'd like to know how low you get off the rail. Do you know what the off the rail velocity is in this current configuration with your simulation as a reference point?
He's gonna
I'm asking you guys a lot of questions as you're still looking. Sorry.
yeah. But the maximum velocity that it said there was around 656 meters per second.
Okay.
Just around like Mach 2-ish.
So you're going to go kiss Mach 2? That's what I'm hearing?
Yes.
I mean, last year you guys were like almost at Mach 1 by the time we get to the end of the rail.
Yeah. We'll definitely have to see. Okay, here we go. So in feet per second, it's 117. So yeah.
Okay. Yeah, I mean, I anticipate you'll probably be going a little bit slower than that then with your adjusted motor profile based on what you've described to me and how that performed in the static fire. Even if that lowers like 20 or 30 feet per second, it doesn't seem so concerning because you already, like you said, you're going pretty fast off the rail.
Yeah.
But if it's getting down there, I'd be a little interested to see what your updated simulation just says for some of your stats. If there's anything like lower stability, lower off the rail.
Yeah. Can you show us the current configuration for rail length that you've got set?
Yeah.
Yeah, he's going to open it right now.
So that's 12 feet right now.
So it's set to 12 feet. So how long is the rail that Ezra provides you?
15.
I don't
17.
in the details. I just
Yeah.
don't remember it off the top of my head. Find it again.
Yeah, we're currently looking it up again. This sim that you're also looking at right now is like still kind of fresh with all the new data. Like you guys also sent us like some pinpoint updates, like letting us know the latitude and longitude, all that stuff. So we're still making sure that everything is up to speed. So
Gotcha. Well, so I think you've inadvertently done what you needed to do anyway with your rail length, right?
Yeah.
Which is what?
Underestimate like
By
how
how much? Like, how do you know what you should put in there?
long?
It's a pretty simple math equation that you do.
I believe I'll be honest, I don't quite remember. I believe it has something to do with the length of the vehicle and position of rail guides, but I don't quite remember exactly what
Right. So you lose the rail buttons provide you stability up until what point?
the top
The first one comes
yeah.
off.
So if it's a 2-point rail guide, the first rail guide that leaves it, that's it. That's all the stability gone from the rail.
So what's the distance of that rail guide from the bottom of your rocket? How long?
We
So the base is 56 inches.
so around like maybe 4 inches off. So around 52 inches from the bottom of the vehicle.
Okay, so that's what I say. I call it effective rail length, right?
So
Just because the rail is 17 feet doesn't mean you're actually going to get to use all 17 feet of that
Yeah.
for stability.
Mhm.
Okay. So I don't know if that was deliberate or a happy accident, but
No, the underestimation of the rail length, that was intentional by me. I initially had it at 14 feet even because I was still we still hadn't for this open rocket that's in front of us, I hadn't imported all the values from the previous one. Like I
gotcha.
said, I like to make new open rockets every time we're updating things. That way, like like even though open rocket is reliable to an extent, you can never be too safe, and like you always want the best data that you can get out of it. So that's why.
All right. Well, anyway, you should just take your rail button length and subtract that from 17 feet, right?
Yeah.
Okay. Cool. Erica, anything else?
I think that's all the questions I got on the simulation. And I think that's most of what I got. I'll ask kind of one more related to the rocket, which is, do you guys have your checklists all made and finalized for the assembly of your rocket, and particularly the arming of your rocket when it's on the pad?
yeah, we have we have those checklists in the oh my gosh, the technical report. So that's definitely something we're going to be printing out and bringing with us.
Gotcha. And you'll hopefully be able to use those at your test launch in a couple weeks.
Yeah, we want it to be almost like a complete test run of the midport.
Yeah. Yeah, good to hear. Definitely like to see that you're doing like the full rehearsal essentially, but those, and make sure that, if you're finding things that aren't good on there, or you're
Yeah.
intentionally skipping steps, or you miss something and you're like, oh, I should have had that on the checklist, just make sure to update those before you get out to Midland. I will request then that you bring those to your final flight safety review. It's not a guarantee, but it's very likely that your in-person flight safety reviewer will ask those and kind of look over them. In particular, they're going to be looking at the things associated with arming on the pad and making sure that the order you're doing things makes sense, make sure that you're wearing the right PPE, just things along those lines. So to be prepared, something to look out for.
Okay.
Thought of one more question I want to ask real quick related to the motor and the tubes. I know that you're bolting that upper sort or the middle tube to the top of the motor, but what is the length of engagement on that joint?
Between the motor and the upper tube,
Yes.
7.5 inches.
All right.
All right. I think that's all the questions I got on the rocket. Anything else, Chris, or anybody else on the team have any other questions or concerns about the rocket?
I got nothing.
I think we're good here.
Yeah, it's looking good. I know you guys still got a little bit of work left to do, and we have those few action items on sending the video after you do the recovery, ejection testing, sending some of that motor information, and sending an updated simulation file once you have your motor details sorted out. That's kind of all I'm really tracking.
We didn't ask opening altitudes. What are you got them here though?
Oh,
Maybe.
apogee obviously, and then main is 1,500 feet with a backup at I think we said 1,300.
Okay. All right.
All right, I'm gonna ask you guys a few logistical questions then. We can close the open rocket simulation just about like trip logistics and making sure that you guys are all up to speed on everything you need to know for competing at Midland. So first one, do you have all of your accommodations and all your travel planning all taken care of, everything all booked?
Yes, for accommodations, we have a Verbo, I believe it was, which will hold all the members that we need there. It has a nice big garage where that we can work in. So that's already booked and paid for.
Sounds good. And what city are you staying in for the whole competition?
It's going to be in Midland, so it's going to be a drive.
Yeah, yeah. And so wanted to make sure that you guys have checked out the distance between Midland and the launch site. It is like 2 to 2.5 hours away. So just
We
something to-
are aware of it. It sucks, but there's not really anywhere else that was big enough that could hold all of us that was in our budget.
Yeah, yeah, it'll definitely be a little bit of a drive, but especially with the no longer having the early launch day bonus, if there's a little bit less pressure on you guys to try and get there at 3 in the morning and cutting out on too much sleep. So of course, we do recommend that you launch early in the mornings, looking at all of the weather analysis we've been doing at the site, and historical weather data. We do expect weather, all things considered, to be very similar to Spaceport America. Particularly in the sense of the winds will likely pick up in the afternoon. The range will likely close past some unknown point in the afternoon when the winds pick up above 20 mile an hour. So just something to kind of keep track of while you're doing your timing and your planning. Don't get there at 2 in the morning, but also don't show up at 2 in the afternoon feeling like you're going to launch for the day.
Yeah. We had our fair share of waiting around doing nothing, waiting for wind last year.
Yeah. Yeah. So we're hoping for the best. You guys shouldn't really have too much in terms of restrictions on when you can launch unless the wind really is just misbehaving.
Okay.
But yeah, it'll be very hot as well, probably a little bit hotter even than in New Mexico, looking at some of the weather, particularly when we're out in the middle of the field. So just something to continue to be prepared for, wearing all your desert gear and bringing lots and lots of water.
Yeah. Off the top of your head, do you know what the humidity is out there? I haven't had a chance to look yet.
It's low. It's a desert.
Okay.
It's
Well,
dry.
better than the other way around.
Yeah, yeah. I'm pros and cons to both. All right, I think that's all I got. I'm gonna turn over to you guys. What sorts of questions do you have? Do you have any questions about the changes in the competition, anything along those lines?
Um, I'm assuming the rails are basically the same rails from last year, just now at Midport.
Exactly. Yep, we pretty much took our connexes full of all of our launch equipment and just moved them one state over.
Okay. The biggest question is is recovery going to change from last year? Because last year there was so much waiting for like the range to clear. And for our team in particular, we lost out on so much time just waiting and waiting and waiting when no rockets were launching, nothing was happening, and we couldn't actually go out and try and find our rocket. And as a result, we ended up like just missing the deadline to turn in our flight data.
Yeah, so there will be some similarities and some differences. Honestly, Spaceport America was pretty restrictive in terms of, their own rules and where we could and couldn't go. But ultimately, we do have some keep out zones for recovery that we will need to adhere to. So the standard one is for, all the pads about 1,500 feet away, 2,000 feet for the two-stage pads. Those zones, those are pretty much keep out zones almost all the time because nobody can be standing there when the rockets are launching. And particularly for solids, right? If you go into that zone and try and recover your rocket while we're racking another salvo, you really likely just won't be able to exit that range or that keep out zone while those rockets are launching. So we may end up had something a little bit similar in that sense for those really tight circles around the pad banks is we can't get out there, otherwise we're not going to be able to launch the rockets until the end of the day. So when the range goes, recovery will remain open, a good reason to continue to target launching earlier in the week. Or if the winds start picking up, if we're truly at like extended range holds, then we won't. But we found that if we're letting teams into those zones to recover, we end up not being able to launch rockets because the teams don't clear the zones fast enough.
Yeah, the small zones around the pads is totally understandable. what happened to us is like we were way out nowhere near the pads, and so we would have been like further than like even where all the tents were away from the pads, and we weren't allowed to go out there even.
Yeah, I will
That's
add.
that.
So those are our ballistic reentry zones. And Space Force was pretty strict on those, but you know, we run last year it was over 1 million simulations just in terms of like those Monte Carlo sims where are expected ballistic impact areas, because in general we don't really want you in those areas as well. If we're launching a full salvo of 20 rockets, what are the chances one comes in ballistic? Probably pretty high. We don't really want you being in those areas as well. So I don't think we're quite as locked down on exactly like how restrictive we're going to be and how big those areas are. A lot of it is, you know, since it's the first time anybody's really launched any rockets out here, seeing where the general landing areas are. We may restrict it a little bit to being like, hey, all the rockets are going over here, you know, keep out of there when we're actually launching rockets, and when we're not, you know, then we can sort of retreat out. We do definitely though understand that recovery was very, very challenging for your team and many other teams last year. So that's sort of being taken into consideration by the folks who are managing the deployment of recovery teams. So Da Vinci, they manage all our GPS or tracking, whatnot. They also manage the recovery folks. So they're working on it to try and, along with our range safety officer, Jim Jarvis, just to balance that. Okay, keep students out of the worst of the areas, but allow them to access the other areas as much as possible.
Okay. You said it's Jim that's going to be the main RSO?
Yep, Jim is the RSO this year in place of Ken, since Ken is going to be out of the country.
Okay, so that's good. I mean, I used to launch with Jim for like 2 or 3 years out in Austin, so I know him very well.
Yeah. Jim's working hard to keep us as safe as possible and keep our flight operations moving as efficiently as we possibly can. So it balances recovery, it balances, you know, at the end of the day, we got to get the rockets off the rail if it means, you know, recovering later in the day. But
Are they going to extend the recovery time? Like, how late are they going to let teams be out
the
actively?
current plan is until sun sets.
Okay. So that's later than it was last year. Is that true?
I'm honestly not sure. Last year wasn't really tracking that, but you know, we're probably going to end up closing down range. You know, if the weather's great, it'll probably close probably around 5 or 6. So there'll be, at the minimum, there'll be a few hours near the end of the day to recover rockets.
Yeah. Slightly cooler part of the day.
But that is true. Yeah, not so fun to go recover your rocket at 1 o'clock in the afternoon.
Yeah.
Emilio, I have a question for you and the team. So how many people are going?
14, yeah.
Taking 14 people. How many vehicles are you taking?
We need to still sort that out, but it's probably going to be limited to like 4 or 5 cars.
Okay. And then are any of those going to be four-wheel drive or otherwise capable of?
We need to ask around and definitely try and bring one of those along.
Okay.
Now I don't know of anyone who has a four-wheel drive vehicle.
Yeah.
Yeah, I would say it, you know, the 4-wheel drive is a nice to have, not a strict requirement. So currently the road conditions not so great, but we are working on doing some like road grading of all the dirt roads that will be the heavily traveled ones. So, you know, we're going to have all the students entering the site and exiting the site. Those will all be graded. Some of the other roads, there's roads that are pretty much in like a 1 square mile grid approximately. It's not perfect, but it's close. Some of those are in great condition. Some of them are not as good condition. And then there's the big empty areas between. Would really not recommend it driving between in those big empty areas at all, just because there's like surface level oil pipelines and other obstacles that can prevent that. But for the most part, even if you just have 2-wheel drive, you'll be pretty good. You might need to walk an extra.
Yeah, I don't expect this. At least I'm hoping that the roads out there are kind of like what they were for Spaceport. At least the ones way out in the boonies. Like they were rough, but there wasn't anything there that a 2-wheel drive like sedan couldn't have managed.
Yeah.
It would have just been quite bumpy.
Yeah, and honestly, I think a bulk of the roads are probably even a little bit better. Some of those spaceport ones were like an ATV went over at one time and now it's a road. So a lot of these ones, like the grid is cars who travel on them, and in many of them, there's like oil equipment that travels in and out of these roads, like tankers, lots of work trucks, things like that, because it is an oil area. So there's a lot of oil facilities within the region, and cars are traveling them. So they're a little better well traveled. The biggest concern is like if it rains, some of them can get a little bit more washed out.
Yeah, that would be my only worry if it rains.
Yeah.
Cool. 14 people, huh?
A lot more than last year.
Are they all going to be Tripoli members?
They should be. I think that was part of the pre-registration. They all need a triple E.
To get a membership, they could actually register.
Yeah.
Yep.
So yeah, they are all triple E members.
Nice.
All right. You guys got any other questions?
I think that's it for me.
Nope.
And the rest of the room is shaking their head no.
We could still have like a tent situation going on, or do we need to bring like our own canopies?
Yep. Yeah, we are going to be having pretty similar tents to last year where they're really massive ones and you'll be assigned a spot underneath. Everybody also, each team gets 2 folding tables. If you want more, you should bring more. There are no chairs or anything included, but you'll get the large structural canopy above you.
Okay, that's good. One less thing we have to carry.
Yeah.
I think that's it.
Okay. Yeah. Well, I'll keep an eye on my email for some of those items when you guys finish those up. And I'd also love to hear how your test launch goes in a couple weeks. Other than that, if you got any other questions for me, don't hesitate to just send them my way. And when we're done with this meeting, you can wrap up the recording, send it over to that general.info ESRA email for our records.
Okay. All right. Yeah. Thank you very much.
Cool. Awesome. I'm excited to see you guys head out there and hopefully you got a good test flight in a couple of weeks.
Yeah, I am excited too. It's going to be a busy month getting everything done.
Yeah.
Awesome,
All
guys.
right. Have a good rest of the evening.
All right.
That's it.
Thank you, everyone.
Bye.
Bye. Okay, I'm going to